into the field. His innovative work includes a patented method titled A Method of Developing Graded Nano and Microcrystalline Composite CVD Diamond Coatings for Tribological Application. A dedicated member of a scientific community, he is a life member of the Tribology Society of India and the Materials Research of India. His contributions have been recognized with prestigious awards, including the Early Career Research Award issued by the SERB ST in October 2006. Beyond his research includes the faculty roles at GM of Technology, research at IIT Madras, research fellow, industry expertise, services, and scientific materials technology with a rich blend of academia and industry. Ravi continues to put bound in technology. Thank you for giving me this opportunity. Welcome you, sir, for the first session of our ATAL FDP. I welcome, sir.
Thank you, sir. Shall I share this?
Yes, sir. Yes, please.
Sir, shall we wait for 2 minutes or continuous?
No. Let us continue, sir, because Professor Ramji sir has already started.
Yes.
Sir, Ramji sir, good evening, sir.
Good evening.
Yeah.
Good evening,
Yes, sir. We'll start now.
Okay.
Yes,
Sir, good evening, sir.
Sir,
Good evening.
Good evening, sir.
Good evening to all the participants.
Chittubabu sir, Professor Chittubabu sir, are you available? Please confirm.
Yes, sir.
Yeah. So without late, I request Professor Chittubabu Garu, Professor, ATAL College Mechanical Engineering Department, to give brief introduction about Professor K. Ramji Garu. He's going to present on advanced robotics for intelligent manufacturing systems. Over to you, sir.
Yes, sir. Good evening, respected sir, my dear colleagues and participants. It is my privilege to introduce well-known academician Professor Kona Ramji Garu, former Vice Chancellor, Dr. B.R. Ambedkar University, Srikakulam, former Vice Chancellor in charge, Acharya Nagaji University, Guntur, currently Professor, Department of Mechanical Engineering and Honorary Director, Center for Nanotechnology and Center of Excellence, Andhra University College of Engineering, AU Visakhapatnam. Professor Ramji sir obtained his BE Mechanical Engineering, ME Machine Design, MTech Nanotechnology degrees from Andhra University Visakhapatnam in 91, 93 and 2007 respectively. Sir obtained his PhD from IIT Roorkee. His areas of specialization include spatial mechanisms, robotics, FEM, tire mechanics and vehicle dynamics. Sir guided 102 ME dissertations, 51 PhD theses and published more than 354 research papers, 9 patents. Sir is actively doing consultancy, research and project works. Sir organized 18 international conferences and 75 national conferences, seminars, etc. He delivered 327 keynote, invited guest expert lectures at different platforms of repute and relevance. He is having 30 years of administrative experience and acted as Chairman Executive Council, Governing Body and Board of Management Member, Chairman Academic Council, NAC Chairman, NBA Chairman, Visiting Professor, Chairman and Member of BOS, Chairman Research Reviews at AU, UGC, AICT, APPSC Expert Committee Member, TechIP Coordinator and TechIP COE Coordinator. Sir visited 6 countries, namely Japan, USA, Australia, Singapore, Turkey and Malaysia. Professor K. Ramji Garu is a recipient of the Best Teacher Award from the Government of Andhra Pradesh in 2010, the Best Engineer of the Year Award from Government of Andhra Pradesh and Institution of Engineers India in 2010. Sir also got prestigious Dr. Sarvepalli Radhakrishna Award for the Best Academician of the Year 2007 from Andhra University, the Best Researcher Award from the Governor of Andhra Pradesh in 2006. Sir also received 9 gold medals for excellent performance in academics, research, consultancy, and best papers published in national and international journals. It is really a great opportunity for all of us to listen to a renowned academician like Professor K. Ramji Garu. May I now request Sir to give his lecture. Thank you, sir.
Thank you, Chittubabu Garu and entire family of ADITYA-TKL-MECH. And welcome to the participants for this particular ATAL FDP. Is this slideshow is visible?
Yes, sir. Yes, sir. It's starting now.
Is it visible?
Yes, sir.
Okay.
It's visible, sir.
Okay, welcome to the participants to this ATAL FDP on transformative technologies in manufacturing. That is in particular Industry 4.0, advanced material and intelligence systems. See, whatever the Professor Chittubabu Garu mentioned, because of the foundation I am got from this university, I brought up all academic credentials from this university as a base. Now today, I am going to cover the topic is robotics for intelligence manufacturing. This is also one of my field of research area, because at this stage I don't want to bore you with mathematics part like kinematic analysis, kinetic analysis, dynamic analysis. But what are the areas where with that analysis, always background, it will be there. Nowadays, softwares are developed, codes are developed, and they will calculate what are the statics part and dynamics part, kinematic and kinetic analysis. With that, we can do number of activities. See, that's what I want to, I'm mostly confined to the robotics for intelligence manufacturing. If you can see, most of the time I am going to give some of these 4 or 5 slides for a mechanical engineering, especially. If you see the branch of tree and compare with the pipelines, or even in the robo joint, can we make a robo of this type of number of branches, number of arms, number of fingers like that, not only the 5 fingers? Can we make as a mechanical, nature is giving a tree in that form. Can we make a system like that? The second, this is the shell, either this form or this form, available in the adjacent to seashore, is having a lot of strength, fracture strength. Even if you want to break it, it is not possible. Can we make as an engineer such a material where robo can be hands, the fabrication of robo can be used, such a high strength material, even especially defense application where enemy is targeting you, nothing will happen like that. This is where the bulletproof, even almost like a bulletproof type. Such a material where we can use. Then if you can compare the shark fish or any fish, maneuverability, can we make a submarine or a ship, floating body and submerged body, such a maneuverability? Or a batteries, smart batteries, if you can call nowadays, you can put in the shirt or a fan to the solar cells, you can charge the batteries. But if anybody can give a battery without charging, can use 1 week or depend upon the frequency of usage, the people are ready to purchase all these technologies. The last one which I am going to present, if you can consider satellite or a fighter aircraft or a passenger aircraft, compare with the bird. See, the bird is having load carrying capacity, which I am not comparing, but maneuverability point of view. The maneuverability of the bird is, it is a naturally, God made the wings, they can land in the top of the mountain, top of the sea wave, top of the leaf. But can we make an aircraft or a satellite without vertical tower, without runways, vertical runway or horizontal runway? Because you know the land is very cost in throughout the world. Runways, if you can take a Bhogapuram airport, the government is collected more than 2,000 acres like that. If you use these advanced material, that is what is today one of the theme of the topic. advanced materials, smart materials, nanomaterials. By using this, if you can create the wings folding, then no need of runways. Only lift and drag force only we are creating wings and rudder, and the other maneuverability is very less. See, because of this, for mechanical engineering especially, these all are the challenges where that we can do with the industry. Today I'm going to give the first part of, because two key themes of this session I want to, one is Industry 4.0, under that the robotics is one of the key technologies. Then what is intelligence manufacturing? How the robotics are using in intelligence manufacturing. Some of the case studies, and we'll make some, at the end we will make some conclusions. See, that's why please, we don't make direct or inverse kinematic analysis, DH notation, Denote-Hartenberg notation, or dynamic analysis. That part I don't cover because that may feel at this stage bored. But I will mainly cover on the, first let us see what is Industry 4.0. See, the Industry 4.0 is a revolution where nowadays the integration of advanced technologies such as Internet of Things, artificial intelligence, big data analytics, and other emerging digital technologies. That is where the intelligence we are creating to automate and optimize the industrial process. See, that's where we can call it a smart factories, highly connected. We can get efficient and flexible. Anyway, if there is a flexibility in the product, we can use this particular system in machines or a system that can communicate each other. See how a machine can take a decision, like Chandrayaan is the best example. Once the landed on the moon, then the Chandrayaan itself is taking a decision. That's what the intelligence, we have to keep it. That is one of the evolution of the Industry 4.0. If you see the Industry 4.0, it touches our daily lives. If you get up in the morning until sleep, it is integrating with the digital and the entire world, physical world. It is not simply a supply chain manufacturing or a business or a revenue growth. If you can see daily life, these are some of the Industry 4.0, how the people are using the gadgets, iPhone, iPad, Kindle, 4G, Uber, etc. And the other, the social medias like Instagram, WhatsApp, Snapchat, Oculus, and Android softwares. We are accustomed to this. This is where, or you can see the timelines. Why does this Industry 4 matter? The evaluation of the computer. The computer is how the first generation, second generation, third, fourth, fifth generation of computers. But see the development, telephone invention, it took 75 years. Web 7 years, Facebook 4 years, Instagram 2 years, Pokemon Go 1 month. See, this is the fast invention is, if you take more time also, you don't have a seat in the at present society. That is the faster rate. You have to catch the society, the customers, millions of customers or crores of people throughout the world as well as in the global level. See, now if you see the industry revolution, the first industry revolution is mainly, that is in the late 18th century, it is concentrated mainly on the water and steam. These are the driven by discovery of steam engine and water power, hydraulic machines, etc., turbines, pumps. Then mechanical production. Before that, only human and like animals only we are using for all this, before steam engine, water power, before industry revolution. Once the industry revolution is started, then the production is taking place with replacing animal and human with the power and machines. Highly labor intensive, that's where the first industrial revolution started. Mostly textiles have benefited with this in the first industrial revolution. Then in the second industrial revolution is confined to invention of electricity, application of electricity, like manufacturing plants, process plants, product development plants, and line assemblies, where the mass production, labor intensive, which we have used. Both case labor is required. But when you are talking about after 19th century, 70s to 2000, Industry 3.0 came into the picture. That is where the digital initiative started. Automation, industry revolution. That's where now we are using robots in that particular intelligent manufacturing and so many other applications. I'm going to let some other case studies where the computation and data analysis technologies and the three elements important: electronics, internet, and information technology. To do, because you know very well, because of automation is increasing, jobs are reducing, requirement of manpower is also reducing. But one advantage for India is youth is there, entire world is looking, because we have hard work nature, committed, lot of integrity. The entire world is looking. Now, even if you see that China is also facing a huge, they are closing the schools. See, that is where the one has to see the development of the technology. That's where we have seen in the automation. That's where we enjoyed this liberalization, globalization, privatization also. That's where it started. Our brothers and sisters are doing multinational companies because of this is the era where the third industry revolution. Now the industry 4.0. That is where we are talking about 2010 onwards, where the sky, until the end of third industry revolution, sky is a limit. People are talking. Now, sky is not the limit. You can reach anything, wherever you want. But here the important point is, you can simulate the system with the digital initiatives, either physical system or biological system. And you can do real-time analysis by adding intelligence. By adding intelligence to the machine. It is a capital intensive, not as a labor intensive. Please understand this. A capital intensive, wherein the skill is required, no doubt, but it is a capital intensive. That is the main theme where the people are going, depend upon the type of investment what we are doing, and accordingly, what is the labor is required. That will be always will be there, and but most of the thing we are using our machines only doing a lot of things. No, the involvement of labor is very minor. That is nowadays we are calling it the cobots. If you can include the human being and robots, combine with collaborative robots, we are called cobots. See, this is where the industry 4.0, if you take any particular system, a cyber physical system is a system collaborating computation elements, controlling physical entities. It is a physical and engineering system where the operations are monitored, coordinated, and controlled by using computers and communication. For any, that is how the physical system is considering in a real life scenario. If you consolidate the things, these are the four industry revolutions. First is a mechanization, then electrification, then automation, then cyber and physical systems at present. That's what I said, CPS or Internet of Things, or digital transformation, or digital manufacturing, or world-class manufacturing. You have to add some value addition, some intelligence to the machine. That's what the main the industry, the present industrial revolution. But another important point, in addition to these four, we have used a globalization also. But today, digitization. Now, future is personalization. Like if you see the medical technology, because of this lot of sensors and actuators availability, you are taking some food and you are leaving as a urinal and tools. If you use a commode, a smart commode, what is the meaning of personalization? A smart commode, if you can use, the commode will like mosquito, how is sucking the blood. Similarly, the commode will suck your blood some frequency, your tools and your urinal. The doctor will monitor the data. Accordingly, the prescription will be given. You will be, if any emergency there, doctor will call you and come and join so and so bed, and not like a paracetamol or a dolo or something else. That type of medicine you don't get. That depend upon the body, depend upon the situation, personalization, the mixing, and you will get the tablet immediately. That's what is the future industry. I am giving one example. like medical field, and in almost all fields, that type of technologies you will see in the industry 5.0. That is what is the future of the technologies. Now, if you compare with what are the advantages, what are the disadvantages of this particular industry 4.0, here it because of this quality increased quantity of the product because of automation, and the cost is also will come down because of the automation, manpower involvement, and errors are reducing, risks are reducing, the accidents we can prevent. Obviously, the productivity and efficiency will increase, and safety is also will be increased. Digital information access, one can get what is the process going, you can see. The new dimensional business competitiveness, you can face challenges, because the point here is if you want to make any change, that can be easily incorporated time to time. Customer service also you take, because that is the customer has to satisfy your good. Customer always require a high quality product at low cost. You should not compromise. Should not compromise on that. And efficient management, ERP, enterprise resource planning, and other things. We can make it. Nowadays, you're seeing e-commerce, Amazon Web Services, or online marketing. See, these all are the why people are using because of these initiatives. Disadvantages, the investment is more. The constant progress of technology, you have to continuously update. The significant economic gap between the companies and the adapting. All companies may not adapt Industry 4.0 based on their level of investment. Require specialized personnel for the skill base. That is very, very important. Personal specialized means skill based persons, not the degree. Increase in unemployment, but India, it is an advantage because of demographic, the entire world is looking. Otherwise, the technology is, because of automation, a lot of unemployment is coming. And it is absolutely depending on the technology. If the technology is not updating, then you are no more in the competition. See, these are some of the benefits of Industry 4.0. You can improve the already mentioned efficiency, productivity, the collaboration and networking, knowledge sharing it will improve. Within a time, you will get the data. You can maintain the experts, what already people have done. If you want, you can compare. That is computer-aided process planning. Improved decision making, improved sustainability. The cost can be reduced, profitability increase, enhanced customer experience. Like these are some of the benefits of the why Industry 4.0 we want to use. The main is the today challenges today in the manufacturing, because that is the topic today. The flexible. Suppose today car is there, in another 1 month or 2 months I want to modify that. See, by using same assembly system, flexible manufacturing system, variety of products can be produced. See, that is one of the challenge that one can meet with respect to by using robots. You can modify this. Optimize the cost, new product, time to time changes can be incorporated. Any level of accuracy can forecast. Supply chain and logistics today depend upon the what is the demand and supply. Accordingly, we can plan the activity on the day-to-day change, weekly change, monthly change. Dynamically, we can incorporate the changes. That is mainly due to automation and the digital technologies. Labor training, skill-based is required, but the specialized persons are required. Industry compliance, industry norms and safety can be easily maintained. These are some of the challenges where with the Industry 4.0, because these are some of the technologies which we have to take care and when we are using this in the Industry 4.0. The compliance, because already regulating bodies are there, you always comply with that. Cyber security, always attackers, they will try to theft your data, they will try to enter your data. How best you are using, you are saving that particular part. Data privacy. Within the family, you have to maintain the data. Workforce transformation, new technologies, adoption to the technologies. Legacy system integration of systems with the new technologies. This is one area where now most of the industries are within India. They are changing they're transforming their companies. They don't remove the machine. The existing machine, they are adding some intelligence. See, this conversion, they are inviting European countries, Western countries, paying huge money and doing the things. As Indians, if we can catch that fruit in the form of projects, definitely we will be there. Still, we are learning means those are the people always will take. When we are reaching, by that time, all industries are converted into they incorporated the intelligence in their machines and try to automate the things. See, this is what you have to see. You have to catch that particular fruit. These are some of the key technologies in Industry 4.0. One is the big data analytics, augmented and virtual realities. Now, suppose today I am here, I am giving a lecture. If my presence I want in another place by using artificial intelligence, virtual reality. This is augmented virtual reality. Lip movements, body movement, I can create and I can plan the things. That is what the additive manufacturing. I hope all of you are already, there's a lot of lectures you have gone through. Cloud computing, cyber security. Now today we are concentrating the robotics, repetitive and hazardous jobs where the human cannot do. And also collaborative robots work alongside of humans. That is where the cobots also. These are the area today we will concentrate. Then simulation. India is very good in this particular part, modeling and analysis softwares, simulation part. System integration, like if you take ISRO and some of the organizations where they are very good in the system integration. Internet of Things, artificial intelligence, machine learning. These are some data science, etc. These are where the technologies, the major 9 technologies, these are the technologies where we are in. Just now I mentioned augmented reality, the reality of maintenance, logistics, all kinds of SOP, standard operating procedures are well developed. They depend upon the industry, depend upon the system, depend upon the, suppose if the education, accordingly we have to modify this. Display of supporting information through glasses, increase people and process performance, decrease cost. This is one of the advantage of this augmented and virtual reality. Where is the big data nowadays? Huge data is generating. That is ERP, SEM, MES, CRM. The machine data is creating. How we are modeling the data? You know, because artificial intelligence is a subset of big data. Again, machine learning is a subset of artificial intelligence. Because of this, real-time decision making can be, because it will give a multiple options, multiple solutions. We can optimize and real-time decision making can be done by taking the available solutions, which solution is suitable to your particular problem. That can be done. Reduce downtime, increase the output, and failure of machine you can forecast. The predictive analysis and that maintenance can be easily implemented with the help of this data. Then autonomous robots. Nowadays we are using unmanned vehicles, autonomous robots, unmanned air vehicles, autonomous robot, drone technologies. These are some of the things where we are using numerous integrated sensors and actuators. That advantage, by taking that advantage, we are using robots in the different areas. We will see that particular topic. The additive manufacturing, it is already, you've gone through a lot of lectures. That's why this is one technology where nowadays we are using by step and see machining, integrating with this additive manufacturing or digital manufacturing, where the digitization is very, very abundantly using in this particular area in the additive manufacturing, 3D printing or digital manufacturing area. See, these are some of the subtractive manufacturing or supply chain management or by using a cloud computing or 3D printing. These are the technologies where abundantly we are using. Then the simulation of optimization part for real-time data from intelligence system. Then another area is system integration. The cross-company data integration, then cloud computing, which I already mentioned. Then the another important point is Internet of Things. Network of number of machines and products. Suppose today I'm out of station, I want to operate my lab. that I can easily do by taking internet. I can allow the students to do experimentation, and not only to operate anything we can do with this particular technology, Internet of Things. And cyber security, I already mentioned. This is one thing, always enemy will be there within the family or within the system or in a national level or a global level, try to attack you, not physically. They theft the data, they may attack the data, they may do a lot of things, and you have to be careful about that. How system, your intelligence system, secure, safe, that you have to see, your software and hardware part. Then what is a IoT is? It is a Internet of Things, refers to anything and everything day-to-day life which is accessed through connected through net. Everything you can operate. Nowadays, this IoT is an advanced automation and analytics system, deals with the artificial intelligence, sensors and actuators and networking and even machine learning techniques, with a lot of transparency and control and performance wise. These are some of the IoT application areas like trafficking. Nowadays, we are GPS by using global position system, we are updating. That's where the Internet of Things, sensors are sending data, and that with the data you can estimate, make the predictions. And cities, traffic control, smart cities, environmental monitoring, cars, condition-based maintenance can be done. Production sites, factories, increased efficiency, optimized machine and offices, retail, marketing, etc. These are some of the areas where people are already using these particular technologies. But as far the manufacturing is concerned, what are the IoT applications? Like digital connected factory, production flow monitoring, the CEO or vice president or president or CMD, they can sit in their house or room, they can monitor what is the production flow. Even nowadays, drones also, if anything going wrong or even machine, any fault is there, crack is there, that monitoring is also doing. Production flow monitoring you can do. Plant safety and security, packaging optimization, smart metering analysis. Nowadays, this city, this is where the smart metering already started. Facility management, inventory management. This is one area where big investment we have to do. That also we can use, depend upon the demand and supply. You can easily balance. Quality, you should not compromise in any system. Always you have to give a lot of weightage. And logistics and supply chain management and automation. This is one area where everywhere nowadays we are taking care of this by using this advent of these technologies. Now, these IoT applications in manufacturing is concerned, mainly packaging, smart metering, safety operations, predictive maintenance, and inventory. What I said previously, where we are using this, like RF inventory management, RFID tag we are putting. Where it is available, you can easily monitor, get the transportation within the less time. See, like that, each one having their own advantages. Then this is what I mentioned, cobots, where robots is having, you can do a number of things, constant speed or a variable speed, favor mistakes, strong and fast, unwanted things can be removed, you can accuracy, precision and can be increased, and hazardous conditions we can use, and they're reliable. Humans are adaptable and they're empathetic, creative, innovative skills are there, critical thinking can be done, trustworthy if they have a skill set, multi-talented. If you combine these two, that's what we are calling is a cobot. Obviously, because of that, the lower the total cost of ownership, investment can be reduced, easily moved and deployable, designed for safety as well as more productive efficiency, and flexible manufacturing system can be implemented. See, these are some of the future factory of the any particular product. This is the where we will see cobots, means few manpower and a lot of robots. This is where we are using IoT technology and industrial augmented reality. That is 9 technologies which I mentioned. Computer vision and blockchain technologies, maintenance, even delivery to the warehouse. The entire process, you can make an automation. So this is where the future factories are looking like this, most of the industries scenario. Predictive mention computer sensor that took onto the machinery, and we can do the maintenance. Continuously monitor how the, suppose a blast furnace, how the process is going, you can monitor. If any maintenance is required, without stopping the blast furnace, you can do the maintenance. Industrial augmented reality, that is virtual reality, already there. Suppose there are 2 lakh photos are there. You have done a function at your house. But I want to take my photos. You can cross-check your image with the existing 2 lakh or 1 crore photos. Immediately within seconds you will get. That's what by using artificial intelligence or the technique where we can use in this particular the Internet of Things, where we are using a sensors or the and net internet. These are the tools where we are using actuators also to track the movement of the product. If any product if some fault is there, you can easily identify, remove. That is where the production flow without hitting the production flow. Then the next part is cobots. I already mentioned it is a collaborative robots where you can easily programmable, can do variety of tasks. Time to time updation also can be done. Modular equipments where the smaller equipment, even in like micro and small medium industries, they can operate variety of products by taking a smaller equipment with some smaller assembly line. 3 degree of freedom, 4 degree of freedom, 5 degree of freedom robots we can make. Suppose a handicapped person is there, fingers due to accident, 2 fingers are gone. That we can make for handicapped person, leg or hand, if anything is missing due to accident or by birth. These things can be done. Anything, even a human being also. The computer vision is another area where we can monitor. Entire thing data will be recorded. Cameras using machine learning to categorize the boxes and warehouse, scan the defect in the to make quality assurance. Suppose 100 samples you take, how many are defective, you can easily remove by using quality assessment activities. Then the customer you give a quality assurance. The another is blockchain technologies for enterprise resource planning, ERP, and supply chain management. Exponentially, these are almost all industries are using this to do more accurate and efficient way. This is where the unmanned trucks and trailers without humans already there in the market to delivery, the commercial delivery. Once it is there, this is where the supply chain, where to drop and where to unload and loading can be done. Then human capital is protected from repeat motions and strain. These things can be reduced. So this is what the two revolution of this particular technologies. Now we will concentrate the robotics. See, the robo deals with the process of design, build, and implement the robots and computer systems to various applications. We will see some of the applications where it can capabilities of robot having play a big role for the different level of application. What is the definition of robo is? A robo is a programmable, multifunctional manipulator designed to move material, parts, tools, or special devices through variable programmed motions for performance of variety of tasks. You can do a kinetic analysis, you can do a kinematic analysis, or you can do anything for what is the objective is to reduce the cost of the production, where the human being cannot enter like hazardous or hostile environment. We can use the robo. Productive quality can be improved, productivity can increase the productivity, improve the management control, everything will be there, keep in control, demand and supply, they can easily meet. And because CAD and CAM activities, you can integrate, computer integrated manufacturing can be done. And it will meet the safety and health administration. These are the two things where we can control. So these are some of the main objective of why we are using robots in the field of manufacturing. The manufacturing, other applications in addition to manufacturing industry, domestic robots, medical robots, nowadays sending tablets to suppose a cancer patient, sending a tablet with a robot. keeping robo in the tablet. While hitting the tumor, it don't affect the surroundings. That's what is the medical robots or agriculture robot, military robots, sports and games. And the manufacturing industry, that refers to the industry where the processing of items and indulge in either creation of new commodity or your existing one you want to validate, you want to add some value addition. There are two things. One is you have to go for new product or existing product you have to modify. Suppose car is there. By using a reverse engineering, you have to modify and entirely you want to design a new car. See, that is where the manufacturing is come into the picture in the industry. This is mainly manufacturing industries are the chief is wealth producing sector for the economy. Any country is growing means manufacturing if industries are coming, employment will generate and the people will movement will increase. Similarly, government will get a lot of money. See, that's where it will affect the economy. That is one important point of this manufacturing industries. Another thing is they will use various technologies, methods in the manufacturing process management. See, because of this, a lot of advantages are there for the entire system. The benefits of this industrial robo is they have a lot of capabilities to produce precise or high quality work, any type of work, any type of accuracy level, even 0.000 decimal also you can meet. Then can be reprogrammed to produce varied products. Suppose customer is always required high quality product at low cost. But by varying quality and cost, we can produce a product. That variation can be incorporated easily. If any innovation, if you want to add in between, that is also possible in the work, in the same setup. Obviously, finally increase the productivity and efficiency of the system. That's what these are some of the benefits. One of the technology which we are using in the present scenario, Industry 4.0. Other applications are related to manufacturing. When is welding? With robo, we are doing welding where a little bit hazardness is there. Assembling can be done, material handling, cutting and polishing, inspection and quality control, and metal fabrication. These are some of the other applications which I mentioned here. Various areas of application in manufacturing sector. I quoted few, but like number. In that, what type of robo you are using, what is the degree of freedom of robo, what type of configuration, what type of coordinate system we are using. That's very, very important. The selection of robo will depend upon the application and depend upon the usage of the type of industry. Accordingly, the robot to be selected, degree of freedom of robot to be fixed. So this is where you have to apply and whether it's kinematic analysis or kinetic analysis, only static or dynamic. These are the areas where we have to concentrate, one has to concentrate. Every robot is having some base, some arm, manipulator arm, gripper or end effector, some drive, sensors and actuators are there. When sensors and actuators, obviously controller should be there. See, then these are some of the things where the basic components of a robot, any robot in a physical configuration. What are the different configurations? Suppose a polar configuration, if you can use the polar coordinates in the present, where you can use the twisting, rotary and linear motion or orthogonal motion, where work volume is such environment, you can select this type of the polar or a cylindrical coordinate system. The second one is the industrial robo configuration, cylindrical configuration, where twisting, linear or orthogonal motion. See, then one can go with this particular environment. Then the third one is a Cartesian, like X, Y, Z, or linear and orthogonal motion if you want, like a rectangular block. The inspection you want to do on a machine which is in a rectangular nature. Then you put some sensors or here you can check the quality, any parameter, roughness or undulation, anything you can measure, then you can decide what is the quality of that product. Then jointed arm or articulated robots. This is where the workspace is hemisphere nature, where rotary and linear motion is revolving type or rotary type one can handle. That type of. See, that's where the degree of freedom we have to decide. This is one of the SCARA robo, selective compliance assembly robot arm, where we can create revolving, rotary, and orthogonal motions, where the work volume is a cylindrical nature. See, that's what I mentioned. The selection criteria of robo is very, very important. One is what I mentioned, the degree of freedom, static or dynamic, and what type of configuration, polar or a cylindrical or a rectangle. That is the basic thing we have to decide. Then what is the work environment? When the working conditions are dangerous and potential hazardous nature, obviously, and also it is affecting the health, we have to go for robo. When the work cycles are repetitive nature, no need of involving a manpower there, you can use one robo. It will do 24/7 operations. That is one of the advantages. And when it is an awkward or humanly difficult to handle a part or tool, either due to excessive weight or awkward location or shape, such things also we can handle. When the process non-stop, like 24/7 manufacturing is a continuous type, non-stopping nature, where the large workforce is required, in those cases also one can select this particular gadget. The robo is a gadget. See, now come to what is the intelligence in the manufacturing. That is the today topic, where we are using a robots. See, the intelligence means in terms of quality and regulation and compliance. Always regulations will be there. You have to be below. Suppose a country below, everybody below that. Similarly, government is having some regulation. You should be follow that. Whatever you want to do, that is allowed. Cost control, cash flow, incoming and outgoing, how the cash is flowing, compression and safety, innovation, growth, and sustainability. These are the key points we have to consider related to intelligence in the manufacturing. What is the intelligence is? Here, combined intelligence of machine, people, and processes and products and infrastructure. If you combine overall, and what is the economics? Because of we are involving a lot of these things, obviously you have to think about economics also. As a result, we have to converge with the gateway for the intelligent manufacturing. What is the meaning of intelligent is intelligent devices where smart sensor controls actuators in the together we are using for doing a real-time analysis. These are we are calling as the intelligence devices for doing autonomous actions where we like unmanned aircraft, unmanned air vehicles, and even Tesla vehicle without driver. These are the things where the intelligent devices, where we are using smart sensors, actuators, and controllers. The second is intelligent people, where the skill-based, highly specialized people across all business functions and in the total global geography, and also real-time they are updating their technology. They also update the knowledge. Then we can use those people we call as intelligent people to include all activities. Because that's why the COBO. If you use such persons and robots, further costs will be reduced. Then intelligent processes, where now the processes means hardware as well as software across the global manufacturing. We can what the best like flexible manufacturing system. You can implement the market changes, dynamic changes can be easily incorporated. So that's where the then intelligent connectivity, because nowadays internet and WhatsApp and social media, you can easily connect, and you can operate by using a cloud. Your step and see, one of my research scholar is done step and see machining. See, that is where by using a cloud you can operate the machine. I am there here. Now I can put my machine in the lab and I can go to my home and I can run the machine. Where I'm monitoring and time to time I'm changing what is if I want to make the job replacement, that I can do by sitting or sleeping at my home. Sleeping means not in a sleeping mode, in flat mode I can manage the things. So the intelligent products End products can be monitored continuously with the sensors. Health of the condition of any person can be monitored. These are some of the future things. And the last one is intelligent infrastructure, like IT infrastructure such as satellite link, Ethernet card, Wi-Fi, routers, and data storage like RAM, hard disk. These are some of the things where we can use and make an intelligence in the manufacturing. So these are the finally, what are the key benefits of the intelligent manufacturing is reduce costs. That is advantage for owner or who an entrepreneur. Maximize return of investment and return on assets, because they will get within a time. They will meet the break-even and a break-even point, and they get the return on investment also. Regulatory compliance and product quality management can be easily met. Quick time to deliver the product. Depend upon the demand, you can increase or decrease the production. Optimize predictable operations, plant visibility, everything you can monitor by sitting at home or while going camp. Also, you can monitor the system. Supply chain management, reliability concepts you can apply. And OE, overall equipment efficiency improvement. Like that, a lot of advantages are there. These are the main advantages. The remaining are obviously the inventory levels, human errors can be reduced, and manpower reduction can. These all are routine things. See, now these are some of the important data. If you can compare, if you take 1,000 robots, industrial robots installation in the year from 2012 to 2022. Asian countries have the maximum users. Next is coming Europe, then is Americans in the industrial scenario. In that, China is the maximum the robots they are utilizing in their industries. More than 4 million robots are operating around the world. If you can see the statistics, this is the source from World Robotics book. We got this particular information 23. Every year on average 10 to 12% increase of these robots in the global level. If we can see the installation, that's what I said. China is out of, suppose if you take the 15 largest makers, if you can use those who are using the robots in industrial environment, 79% out of, if you take 100% as a scale, 17% is the top market in China is almost, see, what is the percentage? 51%. Japan is having, people are talking about Japan, but Japan is utilizing only 9%. United States 5%. Japan will make the technologies, but commercialization and delivery will be done to the other countries. That's what is the mean. United States only 5%. Republic 1%. Germany 7%. India. See, this is where the growth of this particular one which we are using. That percentage what we are using, number of is black and pink color is different. What is the increase in the percentage of that particular year, and another one is what is the total percentage. See, where is India is concerned, if you talk about that is 8.5, Germany is 28, like that. But maximum user is China. That's why they have captured the entire world market. And flexibility. At any cost, at any quality, they are ready to supply because of this technology, what they are using. Then annually in installations, if you see in the up to year 20, this is also World Robotics 2024 data up to 23. Application areas, mostly they are using handling, then welding, then assembly, the cleaning, dispensing, processing, and all others. That means industry, they are using mostly in industry handling part, then welding part, where is a clean room, where more number of people cannot enter. There we are using robots. Then the other is a very, very small applications. Okay, this is where the people are using robots in different. See, now let us come to the last part of presentation is a case study. In another 1 hour, half an hour, where the people are using these robots in the different applications. See, the main thing I already mentioned, to increase the precision and accuracy and efficiency and speed, the robots we are using. to perform any types of task with minimum error and maximum accuracy and precision, increasing overall productivity. That is the object, that is the motive which we are using robots. What is the latest trend is artificial intelligence integration, IoT connectivity, and machine learning, along and skilled, specialized manpower, also humans we are using alongside. And we are doing a real-time monitoring and optimization of this manufacturing system. By taking these two advantages, the cobots having enhanced the working safety also along human beings or those who are working in that particular handling repetitive tasks or even hazardous cobot can be used, and little bit human intervention. So these are some where the complex and value added that is a system with streamlined, well-established flow will be there. Day to day, it will be planned, dynamically can change, enhance the total manufacturing efficiency. What are the workforce implications? Are mainly high-skilled positions. Increased robo can lead to job replacement, but also create opportunities for high-skilled person. That's why skill is there. The people are ready, even if you are first, second class, or that is not the criteria. How innovative, how creative, how what is the skill set you have, accordingly your salary will be fixed. Workers but need training because this is a specialized equipment they want to they have to handle. They should update the knowledge. More technical roles they have to play. See, then these robots improve the product quality as well as manufacturing. The standards you can easily meet, reduce the waste, and enhancing the customer will satisfy this. This is one of the way Tesla Gigafactory employs advanced robotics for battery and car production, enhance the efficiency, reducing labor cost. This is what already there in the market, Tesla car, where without driver we can run the vehicle. Then IoT, if you can use IoT integration, enhances the robotics for real-time data, where we can use scheduling, especially the overall the maintenance as well as predictive maintenance, and overall efficiency can be improved. And the safety part is where we already mentioned hazardous or where more safe is required for human extreme environment, cold weather conditions, where the material which are very dangerous. These environments we can easily handle by using these robots. Another is a lean manufacturing principle, where minimizing the waste, improving the process flow, and increase the efficiency. That is what just-in-time production technique you can tremendously use. Reduce inventory excessively because RFID tag is there, where it is available, you can easily identify, and depend upon that availability, you can place an order. That's why investment to an inventory can be reduced. So this is where another important is what are the challenges? Challenges is high initial cost, because to purchase a robot you have to do the huge investment, complex integration processes, skilled manpower. These three are expensive. One has to spend on that huge money and requires some strategic planning, investment in training, and collaboration networking. These are some of the things we should be dynamic in nature in the industrial robots. It influences the cost, reducing the labor cost, minimize the error, enhancing the efficiency, and long-term savings can be easily done. Even if you taken a loan or anything, that can be easily well planned when you will meet, when you will pay back. Those things can be easily done. Then customer, what is the role of robotics in custom manufacturing? With this allowing rapid reconfiguration, adoption of new tasks. Suppose a customer asking some modification, that you can easily incorporate. Both size and shape or any parameter which is required, personalized you can produce, not like a bulk production. In the bulk production, you can change from person and customer satisfaction. You can easily, that much flexible you can create. Then how do robot handle complex tasks in manufacturing is by using this IoT and AI/ML techniques. Now we can do high precision and a high quality product can be produced. What are the environmental benefits, sir? They are sustainable without spoiling any environment, any side effects, because the robot is replacing a human being. Obviously, these are the environmental friendly manufacturing process. Scrap, decrease the scrap, improve the efficiency, and may impact supply chain. Supply chain pain tremendously. You can easily, it is there in your control. The demand and supply you can easily meet. Speeding the order depend upon the demand and streamline all logistics and distribution processes. Then future trends include this. Obviously, the future technologies is one nowadays we can say AI and ML integration. Most of the Indian industries now they are shifting the existing machine. They are adding intelligence. They are converting the industry to the automation. Most of the industries. How do robots support continuous improvement in manufacturing is you can provide, you can, the data can be monitored. Any bottleneck is there that can be removed and the process enhancement can be done. By reliability or automate the things, the manufacturing process, time to time it can be done. The global market outlook of robotics in manufacturing is by 2025, people are expecting the projected $40 billion going to spend in the widespread adoption and innovation of this in this particular area of technology. Those who are doing really good, this is one area where you can select. This is one of the modern manufacturing and various sectors people are using. And competitive, you may be always in a competitive in the global level. Labor shortage, these are the problems. You can you don't suffer because of these things by using this intelligent manufacturing. Robotics become a cornerstone for these particular activities where the key benefits of robotics in manufacturing is one is enhance the productivity efficiency, streamline the workflows, high precision tasks, improve the product quality, which I already mentioned, cost reduction, long-term savings. You can, despite of high initial investment, you can reduce the long-term savings as well as labor costs, safety and ergonomics. Handling dangerous tasks can be, such type of tasks can be controlled. Then flexibility, scalability easily can be done. One is a flexible, depend upon the customer requirement. You can easily incorporate the modification and scalability also. That is another area where a robot enable to manufacture to scale any operations, depend upon the market demand, maintaining agility as well as competitiveness. What are these particular manufacturing process to achieve? Final thing is efficiency, quality, and the flexibility. If you want to sustain in the market in a long-term competitive, these are the three parameters like you can call as Brahma, Vishnu, Maheshwara for any intelligent manufacturing system. So there is a rapid growth in robotic adoption. Suppose in the global, as of 2021, over 3 million industrial robots were operating worldwide. By 2025, people are expecting 4 million. This is one of the sources, International Federation of Robotics. 1 million will increase within 5 years, within 4 to 5 years. Then market expansion. The robots market is expected to grow a compound level of growth of rate of 10.5% from 2021 to 2027. Countries like Japan, Germany, and South Korea, they have robotic density. With Japan is having 300 robots per 10,000 employees. That with 10,000 employees work, you can easily manage with 3 robots in the manufacturing sector. That is what is the Japan reported in one of the World Economic Forum. Rapid adoption in China, I already mentioned in 2021, China accounted 45% new robo installation globally. See, this is what then finally the advantage is economics and employment impact. Job will be reduced. The robots, because of automation, 85 million by 2025 by reduce. That is what the estimation. But they are also expected to create 97 million new roles, that is specialized and skilled persons. One side reducing, another side those who are skilled, specialized skills between humans and machines and algorithms. We want to marriage between these three. See, that is where that job potential, there is no decrease. Economic and employee enhanced efficiency and competitiveness. Increase the efficiency and you should be there in the market if you maintain all this. Last one, we will see the case studies in automotive industry, electronic manufacturing, and where the industrial robots are using to handle. By 2025, people are talking about is expected to exceed 60 investment of $17 billion. Now let us see what are the different areas where the cobots are using. The TIG welding, this is where the cobot we are using. Process mechanization, here we are having a technical features like adaptive controller, CNC integration of this robot, where there is a hazardous environment, no need of you standing there, you can, and electronic control. Like you can inert gas shielding, these all managed, these argon and helium gases, a lot of contamination, that these can be easily handled in the process. Then MIG welding. This is another area where wire feed gas control can be accurately you can control, and adding a steady supply of filler material, and real-time monitoring and path planning can be easily controlled by using different algorithms, and you can execute precise you can do the welding. Any complex shape can be produced. These are mostly using in aerospace and automotive applications where the quality is a prime factor. Then using artificial intelligence and artificial neural network in cobot welding, the people are tremendously using in AI, where precision and consistency, real-time monitoring, adaptive learning, and predictive maintenance. These are the things. And again, ANN is using by using different algorithms like artificial neural network or convolution neural network or direct neural network, like that. So many neural networks algorithms are learning techniques that mimic the structure, like mimic the human brain to solve the different operations or calculations. The artificial skin, suppose at the age of 70 or 60, your skin is folding. If you want to become a smart, that is where we can put a sensor when the skin is folding. That is where artificial skin you can put it, and at that time also you're looking like a smart. This allows the cobot to become more intelligent, and you can, because your sensor and actuator, that is where you can make something like this. Similar to the robo you can do, where worker safety can be improved. This is where the high velocity and high impact, or low velocity, low impact, and you can meet some safety norms also while using this worker safety. Agility of robo, where the bipedal robot designed for warehouse factory. This is already there. People are implementing. Any robotics, animal. This is where we are using quadra robo used in industrial automation. It is where using transverse complex terrain. Even not a road is rigid. Even like a dog robot, snake robots, etc. Different types of terrains where we can mimic the things. These type of robots. The another is Tesla. Tesla using the repetitive and risky tasks in manufacturing to make that particular vehicle in the flexible. Time to time they are changing, optimize the things. ABB is a company where they are ABB robo designed for precisely assembly, handling operations. This is one robo. They are using for even they are using vision-based system also there. Cameras continuously monitor the system. Then the next one is the BMW engine monitoring continuously. What is going inside the process, like P-theta diagrams and how the process suction. These all things we can monitor by using cobots. In the entire assembly line also you can monitor. The main problems, it can be excessive strain on workers due to repetitive ergonomic, that can be overcome. Flexibility in assembly line, reduce the worker fatigue and injury. And the sources are given where this source is available. If anybody want more data, you can go static, dynamic, and other analysis and other data. This is where the KUKA robot, this is one of the well-established company in Airbus fuselage assembly. People are using the, especially in aerospace industry, with high precision drilling and fastening installations, operations in the aerospace industry with a lot of accuracy and precision, even in a straight surface as well as curved surface. You can see there that particular surface is a curved surface. The concave or convex nature we can handle. Reduce the cycle time and significantly improve the precision, enhance safety and environment, even hazardous environment you can handle. The next one is a FANUC robots, where Nissan engine production line, they are using FANUC robo in their industry. They are very fast, high repeatability is there in the assembly process. Even risk in manual handling heavy engine components, there where we can use lifting or lowering or any such things can be easily handled. Not like a crane. The robo also you can use until certain extent in the assembly quality level. Then Tesla's Gigafactory automation in the Model 3. This is a Tesla vehicle, how they are using in the electrical vehicle, battery packs. Large scale demand for, they have a need of to ensure safety and high speed production. Rapid scale they can use, and real time analysis also they are doing. This is another ABB robo, flexible packaging lines in Nestle company in the packaging industry. They are using pick and place operations. The next one is a collaborative robo integration of Ford's transmission plant. They are using this Ford company, they are using to problems can be avoided of fatigue and repetitive tasks, or a rapid and precise torque control to maintain the quality. One can choose this. These are the companies, what type of robo they are using. The case study we are presenting. But depend upon the situation, we can make a, and another thing is what is the degree of freedom, what is the workspace, work volume. That also one has to see. The another one is Ashikawa Motorman robo for CNC machine tendering, where we want to implement robots, automated machine tendering in CNC operations by using AI-based scheduling. The unproductive downtime and machine, the ideal loading, while some parts loading and unloading, and the labor intensive tasks can be considered. A lot of benefits are there, continuous operation even during off-peak hours, improved machine utilization. These are some of the advantages. This is another thing is AGVs. I think everybody is familiar with this, where the Amazon Web Service, Amazon and other companies, they are using this. The John D and smart material handling system, where automated autonomous guided vehicles, people are using either in this form. The universal robo for electronic, because very small component electronic, if you want to make a PCB circuit, the transistors, ICs, etc., if you want to assemble, where we are using a universal robo for that particular operation, where the precise and repeatability tasks can be done. Then the next one is KUKA Iowa cobot for medical. Nowadays, surgeries, the medical drug delivery, these all we are doing with the medical devices, with the robots only. KUKA is the one area, they are very good in this particular area. But only the thing is customer, that is the patient point of view, little bit expensive. but side effects will be very, very less as of now. See, now the another important area, FANUC vision-based inspection for PCB manufacturing. The printed circuit board manufacturing, where we can use the vision-based systems. Then FANUC is using 3D vision systems to inspect solder joints, component placement on a printed circuit board at a correct appropriate place. Human errors can be minimized. These are some of the advantages where by using this type of setup. The next one is AI-powered robot welding in Boeing aircraft. In aircraft, while doing welding, different components. So this is one of the power robot, Airbus or Boeing. These are the companies where they are using this type of robots. Autonomous mobile robots. The Siemens is a company, Siemens electronic plant. They are using this type of robot. They are deployed for transport component between workstation to the other small factories where we want to execute the communication between these two. These are the robots people are using. And Honda robotic paint shop. This is one area where we can use a little bit hazardous nowadays. After COVID, especially there is a blockage inside these are the environments where a lot of effect is there. See, that is where we can use AI-driven robots. So they will do paint up to even any scale, nano, micro, or even any particular scale we can make it. Nowadays, that is where the nano coating, Rita car, they are calling as a nano coating. That's where the robo-assisted metal additive manufacturing, especially GE company, General Electricals, they are using these robot arms for wire arc additive, especially in additive manufacturing area. They are using to handle this type of robot. The another is Toyota's intelligent robotic assembly with machine learning techniques, where we can make the complicated tasks, the assembly tasks, any assembly can be done easily by using faster changeovers and minimal robot reprogramming. This is the advantage of this Toyota intelligent robots. And then another one is exoskeletons and cobots, especially in ergonomic assistance, General Motors. These are the big companies. What are the different type of robot they are already using in the real life scenario? The another is adaptive robotic sorting in Adidas Speed Factory. They are using this type of newly piloted Speed Factory used robotic arms, where the automated vision systems are they are using. Update, there is augmented virtual reality application. They are using, they have some problems, some benefits. Always the pros are there, cons also will be there. The inspection quality is one of the important point where we can use robots. Bosch company, they are using this type of robot for inspection integrated with AI technologies, especially for automotive components. Then digital twins, where digital simulations to program and optimize the robotic assembly lines for turbine components like a LP blade or HP blade, where the high temperature up to 1600 or 1800 degrees centigrade they are handling. See, that's why where we have to make some simulations before deploying into the actual environment. That area, these are the twins where the Siemens is very good in this particular. These are what I mentioned, Amazon, for where especially e-commerce applications, autonomous mobile robots of a company, Kiva Systems, they are using. Amazon is, I think nowadays, you know very well, they are the maximum salary paid persons by using Amazon Web Services concept. Then Foxconn automation company, iPhone assembly. These are the, you know very well, Foxconn is one of the major electronic company which employs robotic arms in semi-automatic stations for assembly of a smartphone, especially machine vision as well as precision tooling. They are using. See, then the next one is a Caterpillar company. They are using robot welding for heavy equipment components. This is as mechanical engineering. This is the routine part, but heavy equipment they are using. This is the type of robot. Then Lockheed Martin Advanced Robotics for Satellite Assembly. Again, this is where the precision, lot of precision and accuracy is required. Even ISRO is also using such type of robots. ISRO is one of the success story of as far as India is concerned. Then Airbus, earlier said Boeing, now Airbus is using automated composite layups for making number of layers composite to make a composite panels in the curved, concave or convex, where the laser guided robots which we are using. They are using carbon fibers is a material they are using in the especially large aerostructures, where the high strain, the stress concentration factor is more, especially in the curved cases, that can be easily handled by monitoring with the sensors, the data. You take a by taking proper feedback. Then NASA, they are using JPL robo assembly line for Mars rover components. Like Chandrayaan, they have a rover, in those cases, they are using these type of robots. The other one is Komatsu, a remote operated robot for component manufacturing. This is the general assembly cars, and most of the companies, they are using this semi-autonomous robots, where we can even Maruti is using this type of things. Flexible packing. This is one company, the Rethink Robotics. Then Redwood Materials Robotic Battery Recycling. That is where the robots we are using by helping artificial intelligence auto technique. So this is where John Deere Robotics Subassembly for tractor engines. Then this is where the Wilson High-Speed Robotics for laptop assembly. Samsung Advanced Smartphone Assembly Robotics. Because the LG chemical robot batteries for electric vehicles. And Coca-Cola palletizing systems and bottling food packaging. The Kraft Hint Robotic, and then JBS Robotic Batching, they are using meat packaging. Then bottle inspection, quality checking, filling can be using AB in view robotics, where the road rails, gas turbine engine, automated gas turbine polishing can be done using a robot polishing cells. Because they are high temperature, those blades, where LP blade or HP blade, where the temperature is almost, they have to resist 1600 to 1800 degrees centigrade. Lufthansa, they are using this type of robot for inspection. That is a technique, MRO robot they are using. This is where the surgery, the Dr. Siemens Healthcare Robot Assembly for diagnostics. Without cutting the skin, you can see the surgeries can be done. That is where the high precision robots, where we can calibrate the even MR scan, etc. Without radiation, we can do. Then Canon robotic lines, printer manufacturing, and Procter Gamble diet production with high speed robotics, and GSK's robot pharmaceutical packing, and Accelera Metals robot continuous casting assistance, and international paper robotic roll handling, component assembly, where IKEA automated furniture component assembly. See, these are what I want to stress. I don't want to give much mathematics, only what are the applications, what type of robot they are using in the different areas. So the application wise, whether it's inspection or whether it's a hazardous environment, whether it's a pick and place or a palletizing or assembly, all tasks can be done in the real time in an industry scenario. See, with this, I completed my presentation. I strongly believe the three things. One is father and mother and teacher. The teacher has to play a lot of role, the use of this technology. How best we are communicating this technology to our students, because they are the future, the engineers or doctors or whatever it may be to this nation, because a lot of demographic dividend, that is the advantage for our country. But how we are making that person a skilled person, a specialized person. Thank you very much for ATAL family for giving this wonderful opportunity to participate in this particular ATAL FDP. Now we will spend some time for any questions.
Yeah, participants can unmute themselves and ask the questions if you have any.
Sir, namaste, sir. This is R.S. Kiran from SVP Engineering College,
Tell
Visakhapatnam.
me.
Sir, put the question in the chat box, sir. Namaste, sir. Namaste, sir. Yes, sir.
What is that? Can you repeat?
Sir, can we pretend that if we go for efficiency, effectiveness, productivity, then optimization, and finally scalability, we can lead in Industry 4.0, sir?
Yes, that is where I mentioned already.
Yes, sir.
If such a thing which we require, the robo is the first device we have to use
Okay,
to do
sir.
all those efficiently.
Yes, sir.
To increase the productivity, accuracy, precision, and in the whatever the parameters you have mentioned. For that, this is one gadget, but only thing is level of investment. What is the level of investment you want to do? That is the thing where you have to decide whether the small scale or a medium or a large scale. Accordingly, you have to compromise some of the parameters. If you consider all this, cost is increasing tremendously.
Yes, sir. But if we use Cobos, sir, can Cobos be useful instead of robots because they're much more
That's why
advanced?
cobots advantage is by skilling the human specialized, by preparing the specialized persons.
Yes, sir.
Some of these things can be reduced. The cost can be minimized. That can be substituted with the skilled person by integrating a robot with the human being. That's what is a cobo.
Yes, sir. Yes, sir.
Specialized
Collaborative,
skilled person, and we are using.
yes, sir. Yes, sir. Sir, I am teaching this Industry 4.0, sir. Can I have your slides, sir?
And that I am giving it to this organizers. You can collect.
Okay, sir. Sure, sir. Please, sir. Thank you, sir. Thank you, sir.
Thank you.
Namaste, sir.
Any more?
Yes. Any other questions? Yeah, Krupa Shankar, sir, please go ahead, sir.
Good evening, Professor Ramji.
Good evening, sir.
I have been teaching this Industry 4.0, 5.0, etc. But the thing you have provided a lot of supplementary and complementary. And as one of our professor asked, I too will request Professor Srihari to get me your material which enhance my capability as well as.
I'm handing to Srihari. Please collect.
Yeah, thank you, sir. Wonderful. Specializes already. Your credentials are far our imagination, and that you have shown me. Thank you very much.
Thank you. Thank you.
Any
Sir,
other
good evening, sir.
Good evening.
Sir, good evening, sir. Sir, I'm Sir.
Chepo.
Sir, the IoT lab is there, na, sir, in Andhra University. Is there any training is given, na, sir, regarding COE, some IoT
in
lab there?
Andhra University IoT lab is there. They are giving a training 1 month, 2 months like that.
Okay.
You can book slots in advance by sending a letter to that particular
our
person.
management is planning to install some IoT labs, sir, in our campus.
That's why already this is sponsored by NASCOM.
Sir, regarding.
Okay,
sir. Regarding Dr. Pallam Settigaru, got any projects, sir?
Pallam Settigaru is in
regarding
Hub. They have started one company in Hub. They have a
because they are giving free of cost or something minor cost. Sir.
They are doing projects as well as they are giving training also. Training to the students on latest technologies.
Okay, sir. Okay, based on the project he is giving us, sir, actually, or is there any company?
That depend upon the level of what is the requirement. Accordingly, they are planning the activities.
Okay, sir.
You can approach and discuss with him what are your organization requirement. Accordingly, he is planning.
Okay, sir.
Okay,
thank you, sir.
Okay. Yeah, one more, Dr. Satyanarayan Reddy garu. Please go ahead, sir.
Sir, I got one question. Okay, how this robotic intervention is going to affect the economy and the employment? In the sense, what I want to clarify, what I want to
I already given some of the statistics that definitely it will affect the the job opportunities. But for India, it is an advantage. Because if you are doing skilling our youth, our demographic, the dividend advantage, if you skilling, then the entire world is looking Indians. Job is not a problem. But with you have a skill set, obviously the entire world is looking Indians first. First priority is Indians. In that way, we can compensate. But obviously, automation is increasing. Jobs are tremendously reducing. There is no doubt about that.
Okay. So here, what I want to, feel is that actually both are going to coexist, is my opinion. That means the skill level at this point of time also will continue to exist. They will have also business jobs to do it at the same time, because everybody is not going to invest that millions of billions of crores of rupees to bring the automation all of a sudden. So that's going to take place over a period of time. At the same time, there will be demarcation. Certain things are required in smaller quantities. Definitely, nobody is going to invest industry 4.4, 5.4 to make those things. So there will be a business where smaller quantities are required, which industry 4.2 cannot handle it, because customization, all that, you can't afford to do it for smaller things. Only for large scale and also the highly demanded projects where the quality is utmost important, like Boeing or Airbus, that kind of thing, it will go. So what I think is coexistence is going to be there, but the ratio we cannot predict at this time.
That's what you said is absolutely correct. What are the case studies I have shown is not as small. All are major industries only. The entire case study is what I presented to you.
Okay, sir.
But you see the China is taken that as an advantage. Dell Computers, it is in USA, but manufacturing in China and supplying to the entire world. See, because the skill set is they are getting a cheaper rate, and by incorporating a lot of robots in the automation, by taking that advantage, China captured the entire world market. Now any country can occupy that seat. Some part or share can be from the Chinese. But India is having a lot of small scale companies. What you said is absolutely correct. Industry 4.0, they may not be in a position to implement. But nowadays, what I am observing, not small companies, but medium scale and big industries, they are converting by applying the Industry 4.0 and AML technologies. But only disadvantage is that money what they are spending, that is taken away by the European countries and Western countries. Our education institutions, our R&D centers, not tapping that fund. That is a huge fund which is going outside the country. If our academic institutions, our R&D institution can tap that money, there is a huge change, benefit for the organization, students, as well as the country also. That's my submission, sir.
Yes, sir. Like there was some small discussion that IoT training center is there. So similar kind of training centers related to the Industry 4.0 things, I think they should start at least university level, so that graduates coming from their college will have access to these training programs.
In our campus, it is there, sir.
Yeah, similar things, not only IoT.
Similar things, but other campuses, because that is where they have to mainly depend upon the collaboration and networking. Some organizations are ready to investment, but the persons who is giving skill, they are that skill set or not, that is a question mark again.
Okay, sir. Thank you very much.
Thank you. Any other questions?
Yeah, probably no, sir. Santosh, can you summarize the session, please?
Yes.
Before summarizing, I am inviting, we have a AHUB center, like IoT NASCOM center, DigiFact, where we are giving training to the students, 6 months, job guarantee, like that. Some of the things are there in Andhra University. This is not for only Andhra University students, this is for everybody within India. But in advance, a slot should be there. You have to online AHUB, go to the website, you can book either internship or IoT related activities where we can do some fabrication, some experimentation work. And 200 companies are there. They are doing aerospace and other areas. Those things you can utilize. That is one of the invitation to all the participants of either yourself or any of your students. You can utilize from our campus.
Thank you, sir.
Thank you very much for giving this wonderful opportunity.
Thank you, sir. Thank you for valuable information like AHA Hub and all. We shall make use of it whenever possibility is there. And I take the opportunity on behalf of everyone. I express my sincere gratitude to Professor Ramji Garu, a renowned professor in Mechanical Engineering Department, for generously sharing his valuable time with us. For the benefit of participants who may have joined late or experienced network issues, I would like to summarize the key takeaways from this session. So the session opened with the quick introduction to industrial revolutions and the outcomes of the industrial revolutions. Sir highlighted various challenges like regulatory compliance, legacy system integration, workforce transformation, etc., faced in the Industry 4.0 era. He also emphasized elaborately on the 9 technology advances like augmented reality, big data, cybersecurity, and IoT, etc. Professor Ramji Garu in his today's session covered how Industry 4.0 integrates cyber physical systems, Internet of Things, and smart technologies, creating highly interconnected and intelligent manufacturing environments. And Professor Ramji has also emphasized the role of basic robotic controllers in enabling automated precision, flexibility, and efficiency in modern manufacturing environments. He elaborated on the key benefits of intelligent manufacturing systems such as reduced waste, predictive maintenance, and enhanced customization capabilities. Through various case studies, he highlighted the applications of robotics in modern manufacturing, showcasing their ability to improve productivity, ensure consistent quality, and support adaptive production processes. Discussions also covered the implications for the workforce, where automation demands upskilling and reskilling to align with the emerging technologies. Furthermore, he stressed the importance of continuous improvement in manufacturing, driven by data analytics, artificial intelligence insights, and iterative refinements in production strategies. His extensive knowledge and insights have been invaluable in understanding these transformative changes, and we deeply appreciate his contributions to this discussion. This meaningful discussion on Industry 4.0, robotics and intelligent manufacturing has been enriched by the vast knowledge shared by Professor Ramji Garu, especially in terms of various applications and functions, to whom we extend our sincere gratitude. I thank you once again on behalf of all the participants and coordinators over here, and from organizers and from our ATAL Institute and ATAL Academy as well. Thank you.
Okay, thank you. Thank you very much.
Thank you very much, sir. As the coordinator of FDP, I am thanking you personally as well for accepting my invitation. Thank you, sir.
Thank you.
Thank you, sir. Thank you very much, sir.
Thank you for nice planning of the activity.
Thank you.
It's all with your guidance and support always, sir. Thank you.
Okay.
So all the participants are requested to fill the feedback form, which has been rolling out in the chat box, and I am sharing once again for your perusal.
Participants, thanks for the participation, and you can give the feedback and leave. And please join us tomorrow 6 p.m. for some more exciting sessions. Thank you.
Thank you.
Good night.